You. You don't need to stay. You can go. Thank you so much. Bye. Thank you. Bye. Okay, so we are streaming live. We will just make sure the Zoom is recording. Okay, great. So we have a bit of a delay. We had technical issues, but normally, yes, we're live. So thanks to wait. And I'm happy to be here doing the 20 minutes live for today. So let's start with our lesson today. Let's bring up the presentation. Okay, it's here. So how's everyone doing? I'm happy to see all of you here. And here's a presentation. My name is Marlene, and I'm part of the education team from Thousand Faces. As you all know, we are launching our Female Founders program today, this week. And but we still wanted to bring content for the educational part and everyone who's interested here. So today's topic is applications of smart contracts. Last week, we already saw already a bit the basics of smart contracts. And today we will continue a bit deeper in this topic. So last week, how did we start? So we already started with smart contracts. And to understand smart contracts, we have to go back to blockchain because the smart contracts are based and stored on blockchain. So what are the characteristics of blockchain? It's distributed, it's encrypted, historical, immutable, it's inclusive and transparent. So we have another lesson, other lessons on blockchain. So if you want to go deeper into those, you can go to our YouTube channel and you can find them there. So this is the basics of blockchain. And important things to remember is, as you can see, it's blocks. It's a collection of records, these blocks, and they're linked to each other. And because of this connection, they're very resistant to alteration, and they're protected using cryptography. So this is just like the general information to remember about blockchain to understand smart contracts. So what did we learn last week? We learned that smart contracts are just like real contracts, like the paper ones you sign or the ones you sign when you buy a house or when you purchase something, and smart contracts are digital. And how are smart contracts defined? We can think of them as tiny computers that are stored inside a blockchain. So here on the right, we are representing a smart contract. So we see the writing, we see a lock because it's secured and it's connected. So these are general things already that we saw last week from smart contracts. So we can go a bit further today. If you remember, we were looking at a use case as an example to really understand how smart contracts work. So we looked at the example of Sam, and Sam wanted to she has a project in mind that she wants to bring to life, and she needs funding. So how is she doing that? She will use she will use the crowdfunding method to fund her project. So let's review this user case. So as you remember, this is Sam and her friends, and she wants to raise some money for her project. So how crowdfunding works is that she sets up a goal of how much she wants to raise, and she goes pitch her project to different people. These are her two friends, and she can go to different investors. And everything here is done through a third party called, it's a crowdfunding platform. In this case, we use the example of Kickstarter, but it can be any example. And she will set a target of how much she wants to raise. Let's say she wants to raise 2 million. And how this works is that her friends, Ashley and Mary, they believe in her project. So these are her supporters, and they will put funds. And so the funds get transferred to Kickstarter. And she will, in the meantime, Sam will contact investors and look for more funds and investors to believe in her project and invest. So she will have to, the point and the target is to target the goal that she set. And in this way, there's two possible scenarios. There's a scenario, the successful scenario. Let's start with this one. So let's say the successful scenario, she pitched to her friends, she pitched to investors, and she actually reached her goal. She reached to raise 2 million euros. So in this case, Kickstarter has to transfer the money to Sam. In that way, the friends have trusted Kickstarter and to give the money, and Sam is happy to receive the money from because she reached her goal. This is a successful scenario. And unsuccessful scenario is maybe the goal was a bit too high for an initial fundraising, so maybe she didn't reach the 2 million. So what happens in this case is that the funds are returned to her friends by Kickstarter. And then Sam doesn't receive anything. So this is how the crowdfunding normally is working. So in both cases, they're either successful or not successful. There's a third party involved in between Sam and her friends, and it's a crowdfunding platform. In this case, we can think Kickstarter. So in order for all these the transfer between Sam and her friends, we need to have a trust in the crowdfunding platform that we're using, because we don't know if Kickstarter will close one day, if they will, because they're keeping the funds, we need to trust that they will keep the funds and do the right thing of transferring the money to Sam. So there's this element of trusting this third party between them. And so how do smart contracts work? Actually, smart contracts, in this case, they will have exactly a very similar system as the one we're seeing now. Except instead of having a third party in the middle between Sam and her friends, there's a smart contract. So we are removing this third party in the middle. But in fact, the system is quite similar. Okay, so let's put a smart contract in place in between Sam and her friends. So we remove the third party and we put a smart contract. So how does this work? So the smart contract is stored in the blockchain, and her friends are transferring the money again, as stated on the smart contract, to Sam. And if the goal is reached, it's in the smart contract. And if the crowdfunding goal is reached, let's say again the 2 million, the smart contract automatically will transfer the money to Sam. In the unsuccessful scenario, where we also have a smart contract, the friends transfer the money to the smart contract. And if the goal is not reached by the deadline that was put, the funds are automatically, I'm saying this word on purpose, automatically transferred back to her friends. So there's no third party involved, it's just a smart contract in the middle. So it's a very similar system as the crowdfunding, except instead of a third party, we have a smart contract. And so what are some characteristics of this smart contract? Smart contracts are stored in the blockchain. So this means that everything that is coded in the smart contract is completely distributed in the blockchain. So if we remember how transfers are working, it means that every movement of money that is done is coded not only from the person who is doing the transfer, but is coded in all the different users. So in this case, when both friends are making transfer to the smart contract, everything, both of them are coded together, and Sam is also coding everything that is happening, and everything is distributed in the blockchain. So all the information is distributed among all the users. That's why we say it's distributed. And what this causes, since all of them have all the information, there's not one single person that is in control of everything. In fact, everything is distributed. So this really makes it very secure, because there's not one single person that can try to manipulate one aspect, because the other users will not let it. So let's look at the two most important characteristics of smart contracts, since they're based on blockchain. So smart contracts as blockchain is immutable. Once a smart contract is created, we have the team create code the smart contract on the blockchain. This smart contract cannot be changed. It cannot be altered. If this smart contract cannot be used for any reason, it cannot be changed. This contract has to be destroyed and a new contract has to be made. But the contract that was made, the smart contract, it cannot be altered. So this is very, very important, because that means that the users cannot come and try to manipulate the data or something. The smart contract, once it's coded for life. And the second aspect that we just discussed is the distribution. So the output of a contract is validated by everyone in the network. One person cannot force the release of the funds, and everyone has to validate this transaction. So imagine, especially now I'm putting an example with two friends giving money to one friend, but in the case where you have a lot of investors, a lot of different key players who are trying to reach this goal, that means that everyone has to validate in everyone's contract, they all have to validate the amount of funds that were received in total, and one person cannot try to manipulate otherwise the others, because all the information is distributed among everyone. If there's alteration cannot happen, because any alteration has to be validated by everyone. So these are very two important characteristics of smart contracts. And so these two make it very, or we can say the value that makes we can trust smart contracts, because they cannot be changed and they're distributed. So not one single person can change it. So this changes the dynamic of having to trust a third party, where smart contracts, they don't need this trust because they have these characteristics. So let's look at smart contracts. What are their properties then? Because of this characteristic that there is not one person who has more power or more say or wants to alter a contract, we already overcome this issue of trust. So we don't have to trust it. We know it's there, it cannot be altered, and so that makes it an important characteristic of smart contracts. And all the characteristics, of course, make it secure. It's in the blockchain, it's distributed, so it's very resistant to alteration. I also mentioned earlier the transfer of money. Once a smart contract, it's stated the fund, exactly how much, by when. Actually the transfer of money, it's done automatically. There's no need for a third party or a specific person to click a button and make the transfer, or it's done automatically because it's all coded in the smart contract of how it's happened. So whether the result is successful or unsuccessful, there's no judgment of how to do it, if everything is done automatically. So these are it's very useful, especially nowadays, to have this automatic response of the funds without having to have a human or a third party to handle that. And of course, since we're not using, once the smart contract is created, we don't need a third party and pay the fees to have this transaction between friends. So these are very nice properties of smart contracts. And let's look at some of the applications. So as we said, smart contracts are very similar to regular contracts and they're digital. So the first place that I will point out to think about applications of smart contracts would be with banks. So we can think about scenarios where nowadays, if you want to buy some property or if you want to study something and you need a loan, it can be often we go to the bank to lend us money. And what a smart contract can be useful in this case is that often they give you the loan and you have to pay it back when a certain limit is stated. So with a smart contract, instead of having to wait for the bank to call or to have the human have to go and set up everything, the smart contract can be created. So it's a contract between you and the bank. And everything will be automatically coded of how the money is transferred from the bank to you and when you will have to give it back. So it really becomes automatic and seamless.